Erica and Chase. This is the second half, so the back side of the notes for section 5-6. We have 4 problems left. 2 of them are story problems, and then 2 of them are like algebra kind of problems, okay? So here's the deal. Population growth. Biologist knows that if there are no inhibiting or stimulating factors, the population of certain types of bacteria will increase exponentially. So like we're taking out any anomalies that will happen, like bacteria growing at super speed or like anything that's inhibiting. What would like inhibit bacteria growth?
Cleanliness?
Cleanliness, sure. Like not enough of a food source, probably, right? Like if it runs out of food, bacteria is not going to grow. So we're saying in absence of all of that, this is how the population of a certain bacteria is growing, okay? We call S of T A. They call it S of T, whatever. But then the rest of it is PERT. This is continuous compounding. P is the initial population. R is the growth rate. We know all of that stuff. All right. The biologist has a culture that contains 1,000. What is that? P. Okay. 7 hours later. That is T. 5,000 bacteria. That is A. That's A. Okay. They want us to write the function for the population. All right, here we go. So A, we have an after amount, which is 5,000. I'm going to move it over a little ways because we got to do some calculations. 5,000 equals 1,000 times e to the RT. R is, we don't know. That's what we don't know. T is 7. Okay, now, this is not what they're asking for us. Okay, they want us to write a function for the population. They want us to write a function after we have solved for R, right? After we've solved for R. So we have to solve for R first, and then like write out what the equation would be, like with A left in this spot and all that good stuff. Okay, so we'll see that here in a second. What would you like to do first? Divide by 1,000. Great. Do not use a calculator to do that.
It's 5.
It's 5. 5 equals E, whoa, equals E to the, let's call that 7R. Can I do that? Yeah? Okay, now, yesterday, the 2 bases that we have are 5 and E, and I cannot get those to be the same number to like break them down, right? So what we did yesterday was we put an ln in front of both sides, right? Okay, now, this is the really fancy thing when you have an E involved in your equation because ln and E are inverses, which means they cancel out and they become like 1. So this is like saying, and the 7R kind of comes down out of the exponent. So this is like saying 1 times 7R, which is just 7R. So we have ln of 5 equals 1 times 7R or 7R. Then to solve for R, all I have to do is divide by 7. Now, caution. If your calculator opens a parenthesis for the ln, you want to make sure you close it before you divide by 7. Otherwise, it will do 5 divided by 7 and then ln of that. And you don't want that. What is your R value? 0.2229 what? 99? 0.2299. That's my rate that it's multiplying at. So about 23% is my growth rate. Okay? They want us to write an equation now, and the equation is going to be like, we calculate the after amount based upon, we still are starting with 1,000, e to the 0.2299 t power. This is what they want. They want the equation ready to go, set up, so that in part B, we can go ahead and plug things in for A and T and solve for the other one, right? That's what they're wanting when they say, write me an equation, okay? They want A and T left as variables so that we can solve for other things. All right, when, that word means we're solving for T, poop. I was hoping we were going to solve for A. That would be nice. When will the population reach 1 billion? Ugh. Okay, so A is 1 billion. We do have to go ahead and put our zeros in. So 1 billion is 1 with, is it 9 zeros? 1 billion. Then we've got 100 or 1,000 e to the 0.2299, and we're solving for t. Okay, what shall we do first? Divide by 1,000. That's going to knock off 3 zeros. So now we're down to 1 million. 1 with 6 zeros equals e to the 0.2299t. Okay, now what? Now we ln both sides. So ln and e cancel out. I've got ln of 1 million, whatever that is. 1 million equals 0.2299t. And then we're going to divide by 0.2299. Just like we did like solving for r in the last problem. How long does it take? A little chunk of time. 60.09. Okay, what is that units in?
Years.
Hours. The 7 was in hours before, so this is going to be in hours now. Okay. Most of the time in a compound interest formula, you have it's in years or whatever, but whatever units you put in is the units that you're going to get out. So if we put 7 hours in previously, we're going to get hours to come out. Got it? Okay. A population of fish in a lake at time t months is given by this function. All right. This is a function that we haven't seen yet. We're going to talk more about him in the next section, 5.7, which is the last section of the chapter. We'll do that tomorrow. But this is not an exponential function because e is in the bottom. This is something called a logistic function. Okay? A logistic equation, not a logarithmic equation. It's different than log. This is logistic equation. And here's how this works. A logistic function is actually what they use in real world examples because a normal exponential function goes like this, right? And it keeps going up and up and up and up and up forever and ever and ever and ever and ever. Okay, that's what like an exponential function looks like. But realistically, population is not going to increase exponential because eventually we're going to either run out of space on the earth, we're going to run out of food to feed all these people. So at some point, it's going to end up tapering off and like there's going to be like a horizontal asymptote, which is like the cap at the top. That is like the max capacity that we could have, and we're going to end up flatlining at that point, okay? Now, that max capacity, this dotted line up here, is this top number of our logistic equation. So, whatever we're saying, if we're talking about population of fish in the lake, it has been determined that this lake will only support 20,000 fish. Otherwise, we'll run out of either space or we won't have enough food to feed all those fish. They're going to eventually die off. But max capacity would be 20,000. It's going to approach that. So logistic takes into consideration the exponential part here, but it also takes into consideration that it flattens out here. So actually, a logistic function is better than exponential when we're dealing with population. That's what they do with when we're talking about like COVID, right? Like COVID, they say COVID is increasing exponentially, but at some point, there's going to be people who recover from COVID, right? And like, they can't just have millions and millions and millions and millions of people forever get COVID because we're going to have people that recover and we're going to have people like that have already had it that are not going to be infected anymore, so it's going to eventually flatten out. So what they really did was a logistic function probably when they were dealing with data from COVID instead of exponential, but whatever. Anyway, so that's my piece on that. All right. Is there a question? James, he's erasing all of my questions. How long will it take for population to reach whatever? So what are we solving for? Time. We're solving for time. Okay. To reach 15,000, where's 15,000 go? The after amount, or the f of t. Okay, so here we go. 15,000 equals 20,000 over 1 plus 24e to the negative t over 4. This is a mess. Woo! Okay, we're solving for t, and t is in the bottom. How do we do this? Yeah. I'm gonna take these two. Did you guys know that we can just switch those two spaces, right? Yeah. Like if you've taken Mr. Moose class, you can know that. Okay, so we got 1 plus 24e to the negative t over 4 equals 20,000. Divided by 15,000, which is like 4/3 or something like that, right? Okay, then what? Still trying to solve for t here.
Just reduce here.
You can reduce. Okay, what does this come out to be? 20,000 divided by 15,000. Is it 4 over 3? Yeah, 4/3 or 1 and 1/3. Okay, we'll leave that as 4/3. Then what?
You're probably going to want to
subtract the 1. I'm going to move the 1 over, so I'm going to subtract 1. Okay, what's 4/3 minus 1?
1/3. Divide off 24. Actually,
This is 1/3. Okay, 4/3 minus 1 is 1/3. Okay, then what?
Divide by 24.
Divide by 24. So I'm going to take this, divide by 24, divide by 24. That is 1 over 72.
Take ln of both sides.
Or whatever that is. What is a third divided by 24? What?
0.1388.
0.01388? 0.01388. Okay, that's what that is. All right, so e to the negative t over 4 equals 0.01388. Okay, then what?
Both numbers.
Then we ln both numbers. Okay, that makes the e cancel off. So negative t over 4 equals ln of that icky junk. 0.01388. Kind of.
Multiply by 4 divided by
No.
Negative 4.
I'm going to times by negative 4
Whoa.
to do them both at the same time, right? So after you get ln of this, take that times negative 4. T equals how much?
17 point.
What'd you get?
One more.
17 point what? 1. And that is in months?
Years.
I think it's in months. I think above it says in months. So about 17 months is when it will reach 15,000. What's my max capacity for this? 20,000. Okay. So maybe by the end of 2 years, like we're at max capacity and they're going to start to die off, right? Okay. All right. Last thing. Last thing. No story problems here. We just have to solve stuff. Okay. Solve the equation. Here we go. These get kind of icky, but then they're really, really super nice as soon as you get to a certain point. Okay. Keep track of where your equal sign is. All right? Good? Yeah? Okay. There's my equal sign. And I have 3 pieces. I have an ln here and an ln here and an ln here. Okay. This 2 can go to the back. So this is ln of x squared equals. I want to put these 2 ln's together, and in between them is a plus sign. So multiply. We're going to multiply this junk and this chunk and go ahead and FOIL. So ln of, let's FOIL that out and see what we get. X minus 3 times 2x plus 1. Okay, if we FOIL, x times 2x is 2x squared. X times 1 is plus 1x. Negative 3 times 2x is negative 6x, and negative 3 times 1 is negative 3. So if I multiply those together, that is 2x squared minus 5x minus 3. Yeah? Good? Ish? Maybe? Okay, so now I have it simplified to this. It looks uglier than it did before, but this is actually not so bad. What can happen now?
divide out, or no, just get rid of
Okay. Yeah, so just at the same way that I could add ln's to both sides. If there's only one ln here and one ln here, I can delete them, right? Now, the deal here is I can't just delete those and this one because I'm deleting 2 from one side and 1 from the other side. So I have to combine those first before I get rid of the ln's. But if there's an ln on both sides, you can get rid of 1 on each, right? 2x squared minus 5x minus 3 equals x squared. Okay, what?
What if there's 2 ln's on both sides?
No. If there's a plus sign in between them, no. You have to, nope. Okay. All right, now what would you like to do?
square root.
Libby, if you were a flower, you would be a petunia.
Let's move this guy over there. Let's subtract x squared. Okay, what's 2x squared minus x squared? X squared minus 5x minus 3 equals 0. Then what? You break it down if you can. What can you multiply to get 3 but add to get negative 5?
Jayden would be like,
3 and
No.
Be a rose with like all this.
What does that mean? Quadratic formula. Negative b.
I could see
Negative b is positive 5 plus minus the square root of, what's b squared?
What?
25 minus 4 times a times c. Shh. All over 2 times a. There you go.
like yellow or red speckles.
Okay.
Pink.
5 plus minus the square root of, what is negative 4 times 1 times negative 3? Positive 12. Plus 25. 37. All over
Claire, you'd be a
2.
puppy.
Does 37 break down nicely?
That's not Libby.
No, so we're going to do that. There you go. That's what x has to be. How many numbers is that?
Claire would be a puppy.
Two numbers. They're ugly decimal numbers, right? X could be this ugly decimal or the plus or the minus of that ugly decimal. Okay? There you go.
Like a cornflower.
Good? Happy with that? Ish?
Done.
All right, let's do this.
It's like blue.
This one. Oh, there's 3 problems
Yeah, it's
below.
not-
James?
There's only two.
James? There's
They're pretty. There's only two.
What?
Are we done, Coach?
Poppy?
There's only 2 problems.
We don't need another hour.
there was 3 right here.
Yeah.
Oh,
Three.
Okay.
Okay. All right. Okay, here we go. Ready? This one is a little bit different because we have this 5 going on in here. So here we go. This 5. Let's talk about how we treat that 5. What I'm going to do is when I have terms that are not ln's or not logs. Shush, listen. Shush, listen.
I think she would be a Oh my god.
Let's get going. If we have a term that is not an ln or doesn't have an ln attached to it, we're going to put it on one side and all the ln junk on the other side. Okay? So let's add ln to this side. Minus 3. Minus 3. And we've got ln of, we're adding ln of x minus 3. Yeah.
That would be ln of x squared minus 6x
Yep.
plus 9.
So plus, if we combine them, we have like this ln plus this ln, and if I want to combine them, I have to multiply, right? I have to multiply. Yeah, so x squared, or x minus 3 times x minus 3 is x squared minus 6x. Do I want to do that though?
Not really.
I mean,
No, we have ln.
because, okay, I'm going to do this. I'm going to do this instead. Erase. We'll see how this works. Let's go this route instead. ln of x minus 3 plus ln of x minus 3 is 2 ln of x minus 3. Shh.
Like a vine.
Yeah, let's do this. Here we go. Let's do this. This makes it so much nicer. Okay, I don't want to foil. Hey, shush, listen. Okay, do you guys see where I get the 2 from?
Yeah.
Watch the 2. Okay, now what can you do? Divide by 2. Hey, that can be nice. We would rather take 5 divided by 2 than FOIL, right? ln of x minus 3 equals, that's 2.5. I would rather do that than FOIL, yeah? Okay, let's do that.
No idea what we just did.
I'm
Okay.
so confused.
Okay, all right, let's back up.
That actually makes a lot of sense.
Back up. So, we had a number here, and we had ln's are surrounding it. So we put the ln from here over to here by adding. But ln of this thing plus ln of the same thing is 2 of those, right? 2 ln of x minus 3. And then we have 5 on the other side, so we divided by 2. Okay? All right, so now here's the deal. This is what we have now. Yeah?
Yeah.
Okay, ln is actually log base e. Agreed?
Yes.
Okay, log base e of x minus 3 equals 2.5. Got it?
Yes.
I don't think in logs. I want to change that to an exponential function. What's the base going to be? E to the
2.5.
2.5 equals
X minus 3.
x minus 3. Let's do that.
Oh, okay.
Hey, now we know where we're at. Now, if we're trying to solve for x, we
E to the
add 3. So take e to the 2.5 power in your calculator and add 3 to it. What'd you get?
Oh.
That's all you have to do.
You have to put
No foiling involved.
15.18.
15.18.
Add 3.
That sounds decent. Got it? Yeah, no foiling involved.
On to the last one.
No foiling involved. Let's do this one real quick, and we will. Ooh.
Can we do homework problem?
Okay, we'll skip this one. We'll do a homework problem. Okay, we'll do a homework problem.
Can we I can see both.
Do number 15. I like this one. Do number 15.
Rachel.
Do number 15. Do number 15. Here we go. Here's your equal sign. All right. What are you going to do first?
Combine them.
Combine the logs. Pluses between them. That means we are going to
This is how much is it? Daisy.
multiply. So we have log of
She's a Daisy.
x squared minus 3x. If we distribute that x through, equals 1. Okay, now, what's the base of that log? 10. I don't have a log over here to cancel it with. If I did, I would cancel, right? But what do we do now?
You can set log or 10 to the 1 is equal to
I make it an exponential function, right?
Yep.
Okay, so the base of the exponent is 10 to the
1
first power equals
x squared minus 3x.
x squared minus 3x. Okay, great. What's 10 to the first power?
110.
10. Okay, now what do I do?
Subtract the 10 over.
Okay, let's subtract the 10 over because Luke wants to make it into a trinomial. 0 equals x squared minus 3x minus 10.
Breaks down into
Okay.
negative
Oh,
5
baby.
positive 2.
Oh, baby. X minus 5, x plus 2. So x equals positive 5. And x equals negative 2. There we go. Okay? There you go. So if there's a log on both sides, you cancel them. If there's only a log on one side, make it an exponential function after you put stuff together, right? Okay? So that's how that works. Got it? 16, you don't have to combine anything. You can just flip it around. Flippity flippity. Okay?
So you can put e to the second.
So ln is log base e. Then you can flip it around. E to the second power equals whatever and then solve. Okay? There's no combining. Flippity flippity. Okay? Got it?
Why can't all problems do that?
I don't know. I don't know. Okay?
I'm supposed to be the correct.
There you go. Goodbye.